Hello class. Today I'm going to talk about the RAID technology. RAID is short for Redundant Array of Independent Disks, and sometimes just say Redundant Array of Inexpensive Disks. Many systems today need to store many terabytes of data, and because a large disk is too expensive, they prefer to use a smaller disk. And the technology of RAID created to reply this requirement. Another point is that if we use several smaller disks rather than one large disk, if something happened for one of the disks and some failures, we can reconstruct data. The basic idea in RAID is to connect multiple disks together. RAID technology, in fact, designed to increase the speed of reading and writing data to create one of several types of fault tolerance volumes, or both of them. With having an array of different disks, we can have large storage capacity. As I said, faster reading the data, and redundant data is the fault tolerance. If I want to give an explanation for fault tolerance, I should say it's the capability of the hard drive systems to continue working after there is a problem with one of the drives. So pay attention, that's important to make the distinction between fault tolerance and backup. Fault tolerance means that the hard drive can continue to function just with a little or no downtime, even if there is a problem with one of the drives. Backup means that you are copying the data and sometimes possibly compressing it to another location for just archival in the event of a disaster. And an example of disaster would be if two drives in a RAID 5, for example, were to fail. The disaster in a RAID technology, if we use the RAID for the RAID more than RAID 0, we will see that we have different level of RAIDs. For the RAID higher than RAID 0, losing one hard drive is not a disaster, and it can continue to its work. So as I said, many different levels of RAID systems there are, and they are different in redundancy, error checking capacity, and cost also. So if we want to know what's the RAID, I can just summarize it this sentence: that is the technology that enables greater level of performance, reliability, and or large volumes when dealing with data, and by concurrent use of two or more hard disk drive. And so the Atlas hard drive we use as two, and we use we should get familiar with two terms: mirroring and stripping of data, and also error correction technologies, techniques, and the parity check. So just let me to say you was a stripping. A stripping means that we segment the data between different disks. The data is it's in origin a sequential data like a file. Then we put parts of this file in different hard disk, and then it allows us for reading data in parallel. You can see in the figure that we have a file data include four blocks, and each block is written in one disk, and we have here four disks. This is the stripping of data. And what's the mirroring? Mirroring means keeping the copies of data on two separate disks. And the hard disk should be exactly the same. And otherwise, just, the risk is with you if you use different hards. And it gives you very good recovery if some data is lost, get it from the other source, but it's expensive because we require twice as many disks. If we have one, disk, we should have two disks to use the mirroring technology. And also write performance can be slow because we have to write data in two different locations. But read performance is enhanced because it can read data from file in parallel. Let's have a look at different RAID flavors. There are many, just RAID 2, 3, 4, 5, but here just I read for you the RAID 0, 1, 5, and 10 because they are the most important, and you will see that RAID 5 is the most common used RAID. Okay, so I want to talk about the parity. What is the parity? Because we use the parity also in RAID 5. You understand the meaning of stripping and the mirroring. Now, there is another concept. The parity is used for error checking and correction. Okay, see here there is two bars. The first one is 101100011. It's 2. And the other is 01101010. Parity checks comes from this, that we compare two bits, and for example here we compare the first bit in the first word with the first bit in the second word. The first one is 1 and the second is 0. Just we talk, if the number of 1 is odd, we consider the parity would be 1, and if the number of 1 is odd, is even, we consider the parity 0 for that. So here we can just write the parity for 2 byte with comparing each single bit with the other bits, the same position in the other word. To actually implement this in the logic circuit, just we use exclusive OR, and it's very easy. But okay, it's not important for you that are forensic students. Just consider we can create a parity for each 2 single bits, and then if a single bit it gets error, is bad, it's possible to correct it. So no need to have the copy of 2 words, and just the parity would be 8 bits rather than 16 bits. Okay, now we will talk about the parity, but now just let's start with the RAID level 0 or RAID 0, just that it just does the stripping. Very simple. You can see here we have the data is 01011, 0, 1, 1, 1, 0. Now we have two disks, so we segment this into we partition this in two segments. The first segment 0, 1, 0, 1, 1 is written in the first hard drive or hard drive A, for example, and the next 5 bits will be written in the hard disk B. So it is not good for file tolerance. If one of the hard just crash, we will lose the data. So provides no redundancy or error detection. The only benefit is that it breaks a file into blocks of data, and they can be written in parallel or read in parallel. In this picture, you can see that if we lose the second hard drive, we will use all of them, all data. It is a stripping RAID number 0. And this again shows the RAID number 0. We have two disks. The file, half of the file is written in disk 0, and the other half is written in disk 1. If this number 0 crash, we will lose all data into hard drive. Okay, now just let's talk about the RAID number 1. RAID number 1 is mirroring, and now a complete file is stored on a single disk. And data is copied to two identical disks, and if one disk fails, we can use the other one. What do you say? So it provides complete redundancy of data. And here the RAID performance also can be improved in RAID 1, because data can be read in parallel from two locations, but it suffers from write performance because it might write the data twice. It's expensive. We need twice as much storage space. If we want to write 1 terabyte data, we should buy 2 disks of 1 terabyte data. So it's twice 2 terabyte. Good. It's mirroring an exact copy of the file, an exact copy of the other one. And it shows the mirroring, the same data in both of them. If we lose one of them, we have the other. Good. And it can continue, no need to do anything. The computer has two controllers, and when one is crashed, it can just from another. Again, RAID 1, you can see, compare. All information is the same in both disk 0 and 1. And now just let me to talk about the RAID 5 disk stripping with parity. Do you remember I talked about the parity? And now this RAID 5 combines use of disk stripping and parity, and no mirroring. In RAID 5, the system calculates the parity as I explained for you, and again I will give an example to make it more clear. And then it calculates the parity and writes that parity into the drive. So you can see in the picture that we have, for example, block A1, block A2, block A3. It means that one, for example, the file A is broken to 3 block A1, A2, A3. But they are written in this 0, this 1, and this 2. But this 3, the parity that's calculated with this 3 is written in this 3. So something you can see is that if one of this, for example, this one crashed, we have block A1, we have block A3, but we lost block A2. But because we have the parity, the system can reconstruct the full, you know, file A and using this. But here, if we wanted to use the um, mirroring, because we have three hard disks with different information, we need another 3 to 6 hard drive were needed. But here just we can write all parity for these three part of information in one disk. So it's less expensive in compared with the mirroring rate number one. And it uses the stripping benefits. Also it benefits from the advantages of stripping, that is for example reading or writing part. So good. You can see here again we have 4 disks, and okay, for the second, for the B file B, we write the block B1 and B2 and this number 0 and 1, and this to consider for the parity, and again block B3 is rated this 3. So you can see in the picture that the parity is not always written in this the last disk. It's just spread in different disks. It's because if for example we the disk one crash, just okay, you can see we lose the C parity, but thanks to God we have C1, C2, C3, so we don't use the C, but we will use the A and B and D, but we have the parity for these three in the other disks. You can see here I have the B parity, A parity, and yes, so we can reconstruct them. So it calculates the parity and writes the parity in different disks for each file. In this slide shows reconstructing data parity, and assume data strip across 8 disks. Correct data is 100111010, and now each bit in one disk, for example. Now we read the data that we read is 100111110. It should be the same of the same of the first data, but in reading you can see the data is not correct. If you see 1 2 3 4 5, yeah, 1 2 3 4 5 6, the sixth, the position 6 is just corrupted, so maybe we'll lose the disk number 6, and so we have the parity. The parity is 0. When the parity is 0, it means the position 6 in this data is shows that the number of 1 should be even. So here in the data we can see that we have 1, and so it should be 0, and just what we flip that because this 2 is in error. So just we use the read data and parity to know which bit should be flipped, and here just we should flip the bit. Is the parity. So about the RAID 5, we can see while mirroring maintains multiple copies of data in each volume to use in case of failure, RAID 5 can rebuild a failed drive using the parity data which is not kept on a fixed single drive. Because data and parity are stripped evenly across all of the disks, no single disk is a bottleneck. drastically improves the performance of multiple writes, and we can write in parallel. It slightly improves read because we can one more disk to use for reading. We can reconstruct the data in case of a disk failure. And also RAID 5 can balance read and write and is currently one of the most commonly used RAID methods. And here is the RAID 5 picture. Okay, we need to talk a lot about this. Okay, if we just, fail, we just lose the second drive, we can construct with using the parity data again. And we have another RAID, and RAID 10 is the last one I want to talk about. It combines level 0 and level 1 strip file and at the same time mirror it. So it's great read and write performance. With strip, it's good for reading, and also it's good for writing, and the mirror is good for reading. And also mirroring is very good for base redundancy. The problem of RAID 10, if you want to compare with RAID 5, is this the most expensive system, but it's very high performance system. This shows the RAID 10. You can see data is stripped between two hard disks, and the hard disk is for mirroring of these two. And so we need again twice of number of drives. Okay, there's a table shows the different RAID features, important features, and here you can see we have RAID 10. It is combining RAID 1 and 0. Also we have RAID 50. It's a combining RAID 5 and 0. And okay, so as I said, we have RAID 2, 3, 6, and thus, and no need to talk about more. The most important, I think, is 0, 1, 5, 10, and the 5 is the most common. So to wrap up the discussion, I want to say RAID 5 has more usable storage than RAID 1 and RAID 10 configuration and provides performance equivalent to RAID 0. It has a minimum of 3 hard disk drives, and there is not any maximum. We can have as many as we want. And because the parity data is spread, again, I repeat, because it's spread across the drive, RAID 5 is considered one of the most secure RAID configuration. Thank you so much.